As we talk about, Pauling and Corey proposed another periodic structure motif, which they named the plated sheet. The beta plated sheet, or more simply, the beta sheet differs markedly from the rod-like alpha helix. It is composed of two or more polypeptide chains called beta strands. A beta strand is almost fully extended rather than being tightly coiled as in the alpha helix. A range of extended structures are sterically allowed. The distance between adjacent amino acids along alpha strand is approximately 3.5 angstrom. In contrast with a distance of 1.5 angstrom along our alpha helix. The side chains of adjacent amino acids point in opposite directions. So a beta sheet is formed by linking two or more beta strands lying next to one another through hydrogen bonds. Adjacent strands in the beta sheet can run in opposite directions, we call the anti-parallel beta sheet, or in the same directions we call the parallel beta sheet. In the anti-parallel arrangement, the NH group and the CO group of each amino acid are respectively hydrogen bonded to the CO group and the NH group of a partner on the adjacent chain. In the parallel arrangement, the hydrogen bonding scheme is slightly more complicated. For each amino acid, the NH group is hydrogen bonded to the CO group of one amino acid on the adjacent strand, whereas the CO group is hydrogen bonded to the NH group on the amino acid, two residues farther along the chain. Many strands, typically 4 or 5, but as many as 10 or more, can come together in beta sheets. Such beta sheets can be purely anti-parallel, parallel, or mixed. In schematic representations, beta strands are usually duplicated by brown arrows pointing in the direction of the carboxy terminal end to indicate the type of beta sheet formed, parallel or anti-parallel. More structurally diverse than alpha helix, beta sheets can be almost flat, but most adopt a somewhat twisted shape. So the beta sheet is an important structural element in many proteins. For example, fatty acid binding proteins, important for lipid metabolism, are built almost entirely from beta sheets. Most proteins have compact globular shapes owing to reversal in the direction of their polypeptide chains. Many of these reversals are accomplished by a common structure element called the reverse turn, also known as the beta turn or hairpin turn. While in many reverse turns, the CO group of a residue of a polypeptide is hydrogen bonded to the NH group of the residue. So this interaction stabilizes abrupt changes in direction of the polypeptide chain. In other cases, more elaborated structures are responsible for chain reversals. So these structures are called loops or sometimes omega loops to suggest their overall shape. So unlike alpha helix or beta strands, loops do not have regular periodic structures. Nevertheless, loop structures are often rigid and well-defined. Turns and loops invariably lie on the surfaces of proteins and thus often participate in interactions between proteins and other molecules. Special types of helix are present in two proteins, like alpha, cadherin, and collagen. So these proteins form long fibers that serve a structural role. So alpha-calcium, which is an essential component of wool or even hair or skin, consists of two right-stranded alpha helix intertwined to form a typical of left-handed superhelix called an alpha helix coiled coil. So this protein is a member of superfamily of proteins referred to as coiled coil proteins. The two helixes in alpha keratin associate with each other by weak interactions such as van der Waals forces and iron interactions. The left-handed supercoil alters the two right-handed alpha helix such that there are 3.5 residues per turn instead of 3.6. Thus, the pattern of residue chain interactions can be repeated every 7 residues, forming the heptad repeats. Two helices with such repeats are able to interact with one another if the repeats are complementary. A different type of helix is present in collagen, the most abundant protein of mammals, and this extracellular protein is a rod-shaped molecule about 3,000 astron long and only 15 astron in diameter. So it contains 3 helical polypeptide chains, each nearly 1,000 residues long. Glycine appears at every third residue in the amino acid sequence, and the sequence of glycine, proline, hydroxyproline recurs frequently. So hydroxyproline is a derivative of proline that has a hydroxy group in place of one of the hydrogen atoms on the pyridine ring. The collagen helix has properties different from those of the alpha helix. Hydrogen bonds within a strand are absent. Instead, the helix is stabilized by steric repulsion of the pyridine rings of the proline and hydroxyproline residue. The side of the triple-stranded helical cable is very crowded and accounts for the requirement that glycine be present at every third position on each strand. The only residue that can fit in an interior position is glycine. The amino acid residue on either side of glycine is located on the outside of the cable, where there is room for the bicyclic ring of proline and hydroxyproline residues. Okay, so that's all for today. Thank you for your attention.